This is lecture number 1 for Math 140. And I'm going to load up the PowerPoints right here. So let's get started. Is everyone with me? Does everyone have the PowerPoints at their disposal so that you can see what I'm talking about? Yes? Oh, I got a thumbs up. I love that. I wish I could. Can I do a thumbs up too? How do I do that? The dots, the 3 dots? How do I do a thumb? Oh, wait, there's like a reactions there on the bottom. Oh, just clapping and thumbs up. That's it? Oh, come on. There's got to be a thumbs down. What? So it's not like Yahoo? I don't get it. No, it's on Canvas. I posted a file on Canvas. You'll find it on the file page, along with the syllabus. So
my Canvas page isn't uploaded yet. Is it possible you can upload it through here?
I can do that. That's not the end of the world.
Okay.
What I do? Share screen? Is that what you mean? You want me?
I'm pretty sure you can upload a PDF or a PowerPoint through chat.
Can you? Amazing. Let's see if I can do that. Would I just kind of like drag it to the chat from the desktop?
I'm not too entirely sure. My professors have done it, but when you click on the ellipses, I think it should show it there.
Hold on, I'm trying that. I'm going to see if that works. Hold on.
Or you can probably drag it to chat.
So I tried to drag it. Does anyone have it on Canvas yet? Could someone thumbs up so I know? Yes, okay. That's an actual thumbs up, not just a virtual. That's like a whole other level of thumbs up. Amazing. But so why is it that your Canvas does not have it?
Oh, because I told you I just enrolled today.
Oh, that's right. Well, that's right. What do I do? What do I do? Okay, I'll share my screen today, but hopefully this won't be an issue next time. Sound good?
Yeah, thank you.
All right, so does everyone see what I'm seeing?
Yeah.
Okay, but you have your own, so you can either look along with me or you can follow on your own. So in chapter 1, what do we cover? Well, we cover individuals and variables. I'm not explaining right now in this first PowerPoint what those are. I'm just telling you what we're going to cover. We're going to cover categorical variables and the ways of displaying them, namely pie charts and bar graphs. We're going to study quantitative variables and the way of explaining, of visualizing them, namely histograms. We're going to interpret histograms. And we're also going to look at another way of describing a quantitative variable called a stem plot. And then we're going to look at a completely different thing called a time plot. A time plot is very, very specific and unique in its coverage versus the others. So statistics. Next slide. Statistics. What is statistics? Statistics is the science of data. If you have to define statistics in some way, that's it. Statistics is the study of data. What do I mean by that? Well, there's collecting data, there's describing data, there's visualizing data, there's analyzing data, there's using data to predict things. There's so many things that you can do with data, but they are all important. And they're all aspects of statistics. In this chapter, we're just basically giving some definitions and talking a little bit about it. And the first concept, and again, interrupt me at any time if I say something which does not make sense, because I'm sharing my screen. I can't really see anyone right now, so you have to do it verbally, not just type something. If you don't have audio and you type something and somebody else wants to say it who does, that's fine too. But someone has to verbally let me know that there's an issue. So the first step in dealing with data is to organize your thinking about data. And we want to make a distinction between two different things, which you may or may not have ever thought about. One is the individual, and the other is the variable. In this example that we have here, we are looking at 4 horses. Old Indies, Storm Chief, Cattle Fires Wind, Whinnier, and Coming Up Slow. Those are the individuals. Those are the objects that we are analyzing. The variables are things or characteristics of the individuals. In this example, how many variables are listed on this page? And again, I would need a verbal response to that. How many, huh?
3.
3. Oh, actually, wait a second. Someone, I guess I can do chat as well. So this works. Okay, so 3. 3 is correct. So, okay, great. 3 is correct. Breed, selling price, and stable. Why are they called variables? They are characteristics of the individuals, and they can change from individual to individual. They vary. That's why they're variable. Can anyone think of any other variables that are not listed here that someone might be interested in when considering these 4 individuals? Weight, 100%. Weight, it's a great one. What else?
Age.
Age, 100%.
Health.
Health, I'm not sure how easy it would be to quantify health, but you know, if you just do it as sick, well, or something very generic, 100%. Height.
The gender of the horse.
Gender. Color. Country of origin. There are lots of things. Average life. Well, the average life expectancy of each breed is that's interesting you say that. When we talk about the variables, we're looking at the specifics for the individuals under study. This horse is a thoroughbred with this selling price at this stable. The characteristics are not averages. Averages are summaries or things that we would get from lots and lots of individuals, which we will get to later. But the variables are the specifics for these individuals under consideration. Does that make sense, Moo? I'm just going to call you Moo because it says Moo, so. Yes? I need a, yeah, it does. Okay, good. So when planning a study, moving down, when planning a study, or simply exploring data from someone else. I mean, how often, you probably guys don't do it much, you know, in college, but you can imagine if you're out there in the world and you work in some field and someone publishes a study of some kind, you might want to actually go over it and see whether or not it looks good, whether or not they made any mistakes, whether or not their data is valid or invalid. So what are some things that you might care about? The 5 W's: who, what, where, when, why. Who? What are the individuals? Who are we investigating? What? What are the variables? Right? What do we care about? It's very important when you answer a question like, what do we care about, what unit you're using. For example, if I'm talking about selling price on the previous page, what will be the unit for selling price? What unit? Dollars, right? It's right there, the little dollar sign. If you don't put that, it's wrong. The answer is not correct. You will not get full credit. Obviously, breed and stable don't really have units. So not everything automatically has a unit, but if a unit is appropriate, put it in there. If you're talking about the weight of a horse, what would the unit be? Not everyone at once now. You know, I know it's a tough question. Pounds. Pound, perfectly valid weight. Excellent. Then there's the where and the when. We'll get to that later. The where and the when is important for various reasons depending on the study, but we'll get to that later. But the bigger question is why? Why are we doing this study? What's the purpose? Earlier today, in another one of my classes, the following question arose. You flip a coin 100 times, and you observe that heads popped up 49 times and tails popped up 51 times. And I asked my students, what do they conclude based upon that data? And they were giving me things like, oh, the percent of heads is this and the percent of tails is that, but that's not what I was looking for. What would you conclude, a non-mathematical conclusion for flipping a coin 100 times and observing 49 heads and 51 tails? What is your conclusion from that? What would you say is a conclusion? I don't know what you mean, it's not a big enough difference.
Could you conclude that when you flip a coin, it's either heads or tails?
Well,
So
but you knew that even before you flipped, right?
Yeah. Oh.
So why do the study if that was the purpose? Right? That's something you knew either way. Right? Ask yourself, why are we doing the study in the why would a person flip a coin 100 times? What can he possibly get from that? Why would he do that?
Maybe they were trying to test the statement that it's always going to be 50-50.
Well, it's never,
Or like,
you were doing great until you veered off at the end, so try again. They were testing the what? Rephrase it. What are they testing? Why would they flip a coin 100 times? To test what?
Luck.
No, not luck.
Probability?
Nope, that's mathematical. I'm looking for something just, even a third grader might say.
Chance?
They just want to know if it's a fair coin. Right? Is this coin fair? A fair coin should be what at the end?
50-50.
Or somewhere in the vicinity of 50-50, right? I mean, you can't really expect exactly 50, but somewhere around there, correct?
Yeah.
So why am I doing this study? I want to see if the coin is fair, right? I don't need any math in that. The purpose for the study is to test whether the coin is fair. What's my conclusion? The data suggests that this is in fact a fair coin. Can I conclude definitively that it's a fair coin?
You cannot.
No, you can never in statistics. Very rarely can you conclude definitively anything. If I want to know the average height of every student at CSUN, to get it definitively, I would need to actually measure the height of every student at CSUN. I can't do that. I don't have the time or the resources. But if I wanted to know the height of every student in this class, that's something in theory I can get definitively, assuming you guys are all honest. So you can get definitive answers, but it's very rare. In general, the question is, does the data suggest one thing over another? That's what we're going for. Does that make sense? Any questions on that? I can't see anyone, so you got to be verbal about this or in chat. If you don't get it, say something in chat so I can see. And if you do get it, say something in chat so I know you're here. And say, yeah, that makes sense. Let's see 50 yeses, I get it. Just scroll down this chat screen. I'm not kidding. I'd like to see that, please. We good? Yes, yes. Yes, 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 yup, yes. A lot of yeses. This is great. This is what I'm looking for. This gives me some, I can tell, or at least if you're honest, this lets me know that you guys are getting it. If I get nothing back, especially where I can't see you, that's, see, that means yes in Hebrew, I believe. Okay, anyways, moving on. So, types of variables. So there's two types of variables, categorical and quantitative. Now these two types of variables are different. We describe them differently. We work with them differently. We do everything differently depending if it's categorical or quantitative, which means it's very important to know which one it is. So let's talk about that. Categorical. That's something which can vary from one object to the other, but you're simply placing them in categories. So for example, breed. Some of them are thoroughbreds in that category, and some of them are Arabian in that category. Can you average thoroughbred and Arabian? Does it make sense to average a thoroughbred and an Arabian? To add them and divide by 2? Does that make sense?
No.
No.
No. Okay, you cannot do math with categorical variables. But be very, very careful. Just because you can do math doesn't automatically make it quantitative. Look at selling price. Can you add those numbers? And when you add them, would that be a quantity that makes sense? Like if I want to know the average selling price of those 4, can I add them and divide by 4? Would that make sense? Yes, why not? That's a quantitative variable when averaging makes sense, when you can do math with them. Can someone give me an example of something that we use numbers to describe where math does not make sense? Where averaging makes no sense whatsoever. Can anyone give me an example of one? Well, what kind of math? Color is not numbers. I'm talking about something that's numbers, but adding and subtracting and averaging makes no sense.
A date.
Okay, date. So things, I might want to divide things, well, once I can do ranking in a second, but I might want to divide things into what occurred the 1st of the month, what occurred the 2nd of the month, what occurred the 3rd of the month. And in that case, 1, 2, 3 through 31 would be categories. Zip code, another great example. 90210, Beverly Hills. 60645, that's where I'm from, Chicago. If you average those 2 numbers, you don't automatically get Nebraska or whatever's halfway in between. You can't average zip codes and get something that makes sense. Numbers on jersey is another great example, right? If I have a quarterback, maybe he's number 9. If I have a defensive end, maybe he's 52. On the average, they make a great running back because a running back will be 33. It makes no sense, right? You can't average. Address, another great example. Yeah, you can't average addresses and get anything that makes sense. Although the way addresses work is they do go in a certain order. So address might be a little more challenging to describe, but we're not going too deep into this. Ranking. So ranked 1st, ranked 2nd, ranked 3rd. The average of the 1st and 3rd is not necessarily 2nd. There could be a big gap between them. Again, great example. It's not quantitative. So just be aware of that, okay? Anytime you're given numbers, it does not automatically make it quantitative. Does that make sense? Any questions on that? Yes, no, maybe we good. Okay, we good. So Nutira is speaking for the entire class apparently. Not saying I good, saying we good. I love it, everyone's good. So here's a question for you. I'd like you to read the question. Don't say or type the answer yet. Just read the question. And then when I say go, I want you to type the letter that you believe the answer is in the box and hit enter. And I want to see those fly by. So I'm going to give you a couple seconds for that. Okay, 5, 4, type it in, but don't hit enter yet. 3, 2, 1, everyone go. This was wonderful because I see a variety of answers, which is great. Okay, I see some B's, I see some A's, I see a C, I don't see any D's. Okay, so let's take a look. In a study of the commuting patterns of people in a large metropolitan area, respondents were asked to report the time they took to travel to their workplace on a specific day of the week. What is the individual? Well, let's define individual again. The individuals are the objects that are being described by data. Who or what are the objects that are being described? They are the people. The respondents, the people are being described. The individuals are the people. Answer is B. What are we curious to know about the people? We want to know their travel time on a day of the week in a city. So all the other threes are information, that matters, but the individuals, the ones that are under investigation, they are the people. So not everyone got it correct, but those who got it wrong, are there any questions? I think this is a great way of doing it, because that way you don't get to look around and see who else is raising their hands like you would in a class before raising it or anything like that. It does not make sense, Ani? Or there are no questions?
No questions.
No questions. So let's have a follow-up. Well, that's just the answer. Let's have a follow-up. Same question, but this time, what is the variable of interest? Again, don't write it yet. Wait for me to call it. But same question, and the question I'm asking to you is, what is the variable of interest? So 5, 4, 3, 2, 1, go. So lots of A's, a D, a B, or was that the last one? Oh no, so we started on E. A, B. Oh, there's a D, A. So mostly A's, which is the correct answer. What are we asking about? They were asked to report the time they took to travel. That's the variable that we're after, the time they took to travel. It happens that they happen to all live in the same city, because we're looking at a large metropolitan area, a specific one. It happens to be in the same day of the week, on a specific day of the week. But the thing that we're looking for is travel time. In fact, let's think about the word variable again. A variable is something that varies, but they're all in the same city. And it's all on the same day of the week. The only one of these that varies, once we've established the people are the individuals, is travel time. So excellent for almost everyone. Are there any questions on that? Are we all good? I hope so. So, oh, thumbs up, love it. Okay, so exploratory data analysis. Exploratory data analysis is the process of using statistical tools and ideas, most of which you don't know yet. We haven't learned these tools and ideas really, to examine data in order to describe their main features. When you explore data, quite often you have multiple variables. You always begin by investigating each variable by itself. In this course, we are going to be dealing with what is called univariate data and bivariate data. Univariate means one variable, bivariate means multiple variables. We're not going to really have any occasion, I don't think, to worry about multivariate data, but you can imagine out there in the world that might be something that matters. So we're going to focus on univariates, one variable at a time, and then the relationship between variables. For example, as a student at CSUN, give me a quantitative variable that matters to you. Grades. Well, grades, A, B, C, D, E, is not quantitative, so fix that a little. What's a quantitative? Huh?
GPA?
GPA. Tuition. Tuition. I wasn't even thinking that. Tuition's a great one, but I was thinking GPA. Right? GPA matters to students, right? It's numerical. And average class size. That's a great one as well. Test scores, of course. Now, of those 4 plus GPA, so of those 5, do you think that there is a relationship between any of them? Units taken, I didn't even see that. That's a great one as well. That's a fantastic one. Do you think that there's relationships between those variables? That as one goes up, another one might go up or go down or affect the other? Sure, right? I mean, just looking at them, the more units taken, how do you think that's going to have an effect on your GPA? So that's a great question I just asked. I have to applaud myself for that one, because I would think that if the number of units, it might bring it down, right? So there's a few parts here. So this is great. Anthony says it could possibly bring it down. Kiana says, well, the more accurate it's going to be, the more units you take. But Yaya says it can go up or down. Yes, so Weston was what exactly? That's what I was thinking. That I think when he meant up to a few units, not years, but that as long as the number of units is less than some cutoff, then it probably doesn't matter too much. Or if anything, it's going to make the GPA go up because you're taking more classes, assuming you're a good student. But once it's too many units, it might go down because you just don't have time to prepare for all the classes. Class size might matter, might have an effect on that. Larger class sizes, less individual attention. Harder to get a good grade when you can't get that individual attention that you'd hope for. Tuition, if you're worrying about finances, you might have a difficult time concentrating on the material. There's lots of reasons that some of these might be related. That would fall under bivariate or multivariate data. But we're going to start with univariate, one variable at a time. Once you've done that, then you move on to multiple variables at the same time. And you always begin, as the slide says, with a graph or with graphs. I can give you 10,000 numbers, one after the other, in a whole pamphlet, or I can give you one graph, which displays the data. And usually it's the graph that is more descriptive and summarizes the material better. So we're going to have to learn how to make graphs. But before we go on, are there any questions? We good? Okay. Distribution of a variable. So the distribution of a variable tells us what values it takes and how often it takes these values. So let's do a simple example. You flip a coin. Do we know the outcome of a flip before we flip the coin? Really? You know what it's going to be? You should go to Vegas, man. How do you know what it's going to be before you flip it? Okay, so you know what it might be. You know all the possibilities, heads or tails, or landing on its edge, or floating in midair forever. Let's ignore those last two. You know the possible outcomes, but you don't know in advance what it's going to be. That's the key. We don't know what it's going to be, but we know what it might be. I believe you. We good in the lingo of this class. Okay. Now, what is the likelihood, assuming it's a fair coin, of getting a heads or of getting a tails? What would the likelihood be? 50% each one, correct? When you give me the collection of all possible outcomes, and you also give me how likely those outcomes are, you have just given me the distribution of a variable. You have to give me the values it might take, the possible outcomes, and how likely those outcomes are. Those two describe a distribution. Does that make sense? So in the case of flipping a coin, heads or tails, is that quantitative or is that categorical? Quantitative or categorical for flipping a coin? Well, what are the outcomes again? Tell me what the outcomes are. No, not the mathematical likelihoods. The actual outcomes are heads and tails. Can you do math with heads and tails? Can you average heads and tails and say it's something that, H, I, J, K, L, M, N, something that begins with the letter L because it's halfway in between? No, you cannot do math with heads or tails. Because you cannot do math with heads or tails, that requires it to be a categorical variable. Remember, the likelihoods are always going to be numerical. Percentages have to be numerical. 40%, 20%, 10%, they have to be numerical. But the outcomes, those are the ones which might be numerical or might be quantitative. Does that make sense? So the distribution of a quantitative variable like we have here lists the categories and gives either the counts or the percent of individuals that fall into each category. In my example was a little different. It was likelihood. We'll get to that later. This one is more of a data situation. So I have 50 students in this class. Let's say I ask everyone what their eye color is. And this many say blue, and this many say hazel, and this many say brown, which I think are all the possibilities, unless you're like a movie character that has one of those weird eyes. So the distribution would be the 3 categories and how many fall in each category. And that will be the distribution of a categorical variable. It lists the categories and gives either the counts, 17, 3, 19, whatever it is, or the percent, 42% of this, 21% of this, 18% of that, and so on. So question, again, we're going to type our answer, but we're not going to put it in yet till I say so. Is the variable monthly rainfall in Michigan a categorical variable or a quantitative variable? So I'm going to give you, oh no, people were responding before I said to put their answer in. Oh no, they're not waiting for my, okay, they're just going now. No, the people started and bam, it just took off. It's okay, we good. Okay, but the answer is B, I don't think anyone said categorical. I don't remember when we started. I think everyone said quantitative, which is nice. Which it is. Monthly rainfall, it's numerical, and you can average it, and numbers make sense. It is certainly a quantitative variable. Okay, this one, remember, wait for me. If we ask people to report their weight, would that variable be considered a categorical variable or a quantitative variable? Again, wait for me, don't say it yet. Categorical or quantitative? 5, 4, 3, 2, 1, go. So I see a lot of people say B. In fact, John said B lots of times. He was really enthusiastic about that. People just said quantitative, which of course is just B. There are some A's thrown in, but for the most part, people say B. Weight, 250 pounds, 200 pounds, 190 pounds, 180 pounds. Can you average those? Yes. Math makes sense. It is a quantitative variable. You can do math with it. If I said a little differently, if I said, I don't care about your actual weight, I just want to know if you're in the 100s, the 200s, the 300s, or the less than 100, then that would be that would be categorical, because now I'm collecting them in these bins. This category, this category, this category, and so on. That could be a categorical variable. Does that make sense? Anyone, everyone, no one, possibly? Okay. All right, question. We ask people whether their weight is underweight, normal, overweight, or obese. Don't do it yet. The question is this variable categorical or quantitative? A or B, 5, 4, 3, 2. He jumped the gun again. Crazy, man. Crazy. Oh, he went again, just 3 times. He really is very enthusiastic, and the answer is, in fact, A. There's no numbers anywhere in this situation. It is, in fact, categorical. So how do we actually go ahead and describe categorical data? We use one of 2 possible picture-looking things. One is called a pie chart, and the other one is called a bar graph. These ones are not to be used for quantitative variables. By the way, what time's class over? 8:15. Okay, never mind. Okay, they are not to be used for quantitative variables. Those get a different type of visual display. So very important. Categorical variables get pie charts and bar graphs only, not the other types. What does a pie chart look like? Well, you've probably seen them before. You might have even heard the term pie chart before. 8 to 10. Oh, 8 to 10 is the time of class over. Thank you. So this is what a pie chart looks like. Okay, it is categorical. Every slice of the pie is a category. And the slices are arranged by percent. So if something can occur 10% of the time, then the slice should cover 10% of the pie. And if something can occur 8% of the time, then the slice should cover 8% of the pie, and so on. So just by looking at it, without even knowing anything about math, I can just look at it, and I can say immediately that which category is the most likely, or at least has the most occurrences. This goes for everyone. Anyone? Mueller? Fry? Huh? Biological sciences, you say? Well, let's take a look. First of all, we have a table. On the table, it certainly says that biological sciences at 14.9% is more than any other. Do you all see that on the left? Yes? Okay. If you actually, oh yes, with capital letters, he really, really sees it. Now, if you look at the pie chart itself, which color represents biological sciences? So orange. How do we see that? Well, on the far right, they list all the categories with colors so we can tell them apart. Very important. And biological sciences is orange. Does it look from the display that biological sciences is the biggest? Well, that and business, right? Kind of. When things are really close, it might be hard to see with the naked eye, which is why it's always nice to also have the table next to it and listing the colors and everything. But sometimes the pie chart itself is enough. It certainly gives us an idea that biological sciences is one of the tops. And which one, just by looking, which color, just by looking, is the smallest of them all? Physical sciences, right? It looks like a magenta, possibly a chartreuse. I just don't even know what color that is. I just know it's a color. Is chartreuse brown? I don't even know. I did it once to my nephew. He was like 6 years old, and he had a birthday party. So I went over to the birthday party. It was like a dinner with the family, and I walk in, and he has name tags, or not name tags, but like little displays, one for each person, and they're all different colors. And one's blue, and one's green, and one's red, and one's yellow. And he looks at me, and he's so happy, and he goes, "What's your favorite color?" And I say, "Chartreuse." and he just starts crying. So it was awesome. What a good day that was. But anyways, I just had to say that story because I'm a bad person. The point is that pie charts are really self-explanatory. It's kind of a green. That's what I actually think I knew that. But it's the pie chart is fairly self-explanatory. But do you see why it only makes sense to have a pie chart for categorical variables? Right? It makes no sense. You know, every slice of the category. Right? Every slice of the category. So pie charts only make sense for categories. And therefore, we only use them for categorical variables. If we look at the next slide, which is pie charts or bar, I think both of them are pie chart. Oh, okay. This says pie chart or bar graph, but it's really just bar graph. So we have the same situation. It's the same situation of 1.5 million full-time first-year students. And actually, before I forget, let's go back to the pie chart for a second, because there is something that I forgot to mention. If you look at the numbers in the table, 10.1, 14.9, ... down to 13.9, you noticed that they do not add to 100%. They add to 99.8%. This does not mean that there's 2% out there that we don't know about. Okay, other majors, the last category, other majors, that already counted for that. It's because it's not really 10.1%, it's not really 14.9% or 13.4% and so on. Each of those numbers is rounded. And when you add the rounded numbers, the final answer is not going to equal exactly 100%. You have what is called a rounding error. Now, if it added to 92%, that's pretty big for a rounding error. Then I might say there's a problem. But as long as somewhere in the vicinity of 100%, you just assume that it's rounding error. Does that make sense? Essentially, I guess you can do it like this. Each one of those values is at most 0.1 off of its true value. And because we have 1, 2, 3, 4, 5, 6, 7, we have 10 categories, the furthest off we would possibly ever be is 1%. So as long as I'm between 99 and 101%, I can say it's round off error. If I was not between 99 and 101%, I would have a problem. Did that make sense what I just said? Any questions on it? I will take your silence as acquiescence. So let's go back to the bar graphs. This is the same situation as it was before. We're just displaying the data in a different way. How are we displaying this data? We're displaying this data with bars. The height of each bar is proportional to its percentage. So if something is 10% versus 5%, it should be twice as high. Not just higher, that's not enough. It should be twice as high. If it's 15% versus 5%, it should be 3 times as high. All the bars are the same color. All the bars are the same width. The bars are all separated. These are all important because if they're not, it can psychologically skew your interpretation. If they're different colors, you might look for a reason why they're different colors. If they're all together, it might be hard to read. If they're not proportional to their heights, it's very hard to read. But at the end of the day, it gives exactly the same information as the pie chart did. So, are there any questions about ways of describing ways of visualizing categorical data? Are we good? Yes. So, oh shit. Hopefully none of you saw that. So the purpose of pie charts and bar charts is to A, hide the data from the audience, B, impress the audience with interesting colors and shapes, C, help the audience grasp the distribution of the data quickly? Or D, display the distribution of quantitative variables? So I will give you 4 seconds. 4, 3, 2, 1, go. So the answer was a pretty resounding C, but I did see a D up above. D says quantitative. Again, pie charts and bar graphs are only for categorical variables. Never. Is that you, Giovanni? I'm going to check. No, it was not you. So what are you laughing at? What does MB stand for? My bad. I got it. You're not going to say my bad. So I guess we're not good. We bad. But anyways, okay. So the correct answer is C. Okay. And this, why are they doing it again? Well, it's the same thing. Okay. Question. Married respondents in a survey were asked how they met their spouses. According to the bar chart below, approximately how many respondents met their spouse through well, that's not good. So I'm gonna pick one. How many respondents met their spouse through a date service? A, B, C, or D? I'll give you 5 seconds. A, B, C, or D? 5, 4, 3, 2, 1, go. So C's. We got a B. B says 20. And date service certainly goes to much closer to 30 than to 20. So I'm going to have to go, it's A. Oh, it's C, JK. He was just kidding. Accident. It's okay. I understand C's and D's can look very similar, especially when they're your grade. Okay, so the answer, let's see what their question was. Oh, it was through a dating service. I guessed right. Look at that. So the answer is C30. All right, next, quantitative data. Before we go on to quantitative data, is there any question on categorical? Are we good? That's like super good, I think. I'm not 100% sure on that one, but I'm going to go with it. So let's look. We Gucci. Oh, sweet. I don't know what that means, but it sounds good. Gucci just has a, you know, like an awesome connotation. So we Gucci. I'm going to start using that one. We Gucci. Okay. Quantitative data. The distribution of the quantitative data tells us what values the variable takes and how often it takes those values. How is it different than a categorical variable? Well, one little difference. That was, it tells us how often the categories occur. And because this is quantitative, I don't have to worry about categories. I can go all the way to the actual values. And we have 2 major methods of displaying quantitative data. There are other ones, and I will give you another one. But the 2 major ones are histograms and stem plots. Histograms also uses bars. So here's an example of a histogram, a couple slides down, that also uses bars, much like a bar graph does. But there's one major difference between a histogram and a bar graph, just by looking, before we even analyze what's going on. What's the first major difference that you see between a bar graph? And there's the answer. The bars are touching. In a bar graph, the bars are separated. They have to be separated. In a histogram, they are oftentimes connected. Sometimes they're separated. It depends on whether or not, let's see if I have another one here. No, it depends on whether, Just scrolling to see if I have one of these notes anywhere. I don't see any, so okay. I'll explain why. So look at this data. This is freshman graduation rate, or FGR. Sounds like a president. Data for 2013, 2014. The FGR data, freshman graduation rate between 60% and 100%. Sorry, not percent. Yeah, yeah, graduation rate, 60% to 100%. And on the left column is number of states. So first, how many states were analyzed in this study? Nope, not 5. Not 30, not 50. Even though there's only 50 states, but it's not
51.
51. 51 is correct. If you look on the far right, there's the count. One state had a graduation rate between 60 to 65%, one between 65 and 70, 5 between 70 and 75, yada, 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 till the end. Why did we get 51? We're only at 50 states. What happened? The answer is probably, I would guess, District of Columbia, possibly Puerto Rico, or, oh, so it is DC. That's my guess too. But there are US, I don't even know what they're called. I'm not really a history person, but, or a sociology.
Territories.
What do they call territories? Territories. So there are other territories, but I'm guessing it's District of Columbia. Anyways, so the count is 51. How many of those 51 states had a graduation rate between 80 and 85%? $11. That's what the count says, right? What if there was 0? What if there were no states between 80 to 85%? What would our histogram have between 80 to 85 if there were no states that had a graduation rate between 80 and 85%? The answer, it would have a gap. It would have no bar. It would have a space. You don't skip the space because the fact that it's 0 matters. It tells me something. So sometimes the bars don't touch, but usually they do. Does that make sense? Also, what if a state had a graduation rate that was exactly 75% to the 100th millionth decimal point? If something was exactly 75%, where would it go? Would it go on the 70 to 75? Or would it go on the 75 to 80? And the answer is, well, it might. It really depends on you setting up the bar graph. It can be either one. It just depends on what on you. You set it. If you say, I want the borders to include the left side, then they include the left side. If you say, I want them to include the right side, then they include the right side. It's up to you. There's no hard and fast rule for that one. And this one looks like they include the left side because it says 60 to less than 65 and 65 to less than 70. Do you see that in the table there? So 75, if I actually landed on 75, it would be, like Dominique says, on the 75 to 80, not on the 70 to less than 75. Do you guys all agree on that one? Does that make sense? Are there questions, comments, allegories, metaphors, similes, anything? Okay, so let's go back to the slide because we haven't quite finished it. Histograms. It's appropriate for quantitative variables that take many values and are large data sets. Usually you won't use it for small data sets or because you really want to have these bars which cover multiple values. If there's not really many values, then there's really no need for that. You can use it, but it might not be the most appropriate. You divide the possible values into classes. They have to be equal width classes. You don't get to make some larger than others. Although sometimes in more advanced classes, the last class, you might say, okay, from here on, that is a possibility. You count how many fall into each class. You draw the picture. And the bar heights should be equivalent to the number or percent, like they are here. Excuse me. So are there any questions on histograms? We good and we Gucci. I guess both is even better. The next one, oh, let's stay with histograms for now. In fact, you know what? The next part might take a little bit to do. So why don't we end here at the next slide? So I'm going to stop sharing. All right. So this concludes lesson number 1. Are there any questions on anything we did today? Seems relatively straightforward. And notice that not everyone answered every question correctly. So as straightforward and simple as some of you might think it is, will you let us know when we have homework? Well, first of all, the first homework will not be due until 1 week after we finish the first chapter. And we haven't finished the first chapter yet, which means the homework is not due. But when I put it up, I will let you know, and the dates will be on there for sure. But nevertheless, don't be lulled into thinking that this course is going to stay as difficult or not difficult as day number 1. It gets harder a lot faster, or not a lot faster, but it gets harder pretty fast. So be prepared for that. Don't be lulled into, I got this. Stop paying attention, and 2 weeks later you're like, wait, what's going on? Don't be that person. Be good, be Gucci. So unless there's any other questions, we will call it a day. And I will see you all on Thursday.
Okay.
Okay?
Thank you.
You are welcome. Good night.
Also, Professor, sorry, did you say that you were going to send the link for the homework, the launch thing, on the email?
I'm going to do my best to get it out to you
Okay.
ASAP.
Because we can do our textbooks on there too, right?
It has an e-text associated with it. That's correct.
Okay. Thank you.
You should close the dry. You should close the.
Can I, yes, if you have a question for me, stay till after everyone leaves and we can talk about it for sure. But if you don't have any questions, you can go and continue to live a life of religious fulfillment.
Have a good night.
Good night.
Thank you.
Thank you.
You're
I
welcome.
came in kind of late. How is the attendance done? Or
How late did you come in?
I came in kind of late. I couldn't find the email at first. I tried looking
Okay,
for
well,
the class.
you definitely get a pass for day number 1 because day number 1 was a little difficult. So hold on a second. So let me go to courses here and make sure that you are included. This was Math 140 Business. And I'm going to go to attendance. And what's your name?
Samuel Sackett.
Okay, 1 second. How late were you in? Were you really late?
I was pretty late. I tried looking for a while. I kept like refreshing Canvas. I thought it was going to be there, and I couldn't find it.
Okay, so Samuel Sackett, here you are. Okay, you're in. I have you for today. Hopefully you don't feel at a major disadvantage after having missed a little bit of the class. Did it kind of make sense, the part that you were here for?
Yeah, I mean, I got here for the teaching part.
Oh, and that's the part that really
So-
matters.
Yeah.
Okay, excellent. Okay,
Thank you.
I will see you Thursday then.
Okay. Yeah, you too.
Weston, you're on mute. I don't hear anything.
Okay.
You can type it if you have a question. I just so you know,
How's that?
that's much better. How you doing?
There we are. I'm doing okay. I showed up late to class as well, between 6:30. 30 minutes to 40 minutes late. I made it just before the lesson started.
So I put you down. I just saw, I had seen your name in chats, and I just put you down for attendance. So I do have you for today.
That's fantastic. So I was emailing you earlier today because I seem to have gotten the chain email for your Math 210 class at 2 o'clock.
So the way it is I teach 3 classes Tuesday, Thursday, back to back to back. So
Okay.
rather than having 3 different Zoom links, I just have one, and I just stay in here all day long.
I am very glad that was the case, because finally 30 or 40 minutes in, I was like, wait, what if it's the same Zoom room? What if I just click the link and I'm there?
And it was.
And I figured, yeah, it was. I was very happy when it all worked out. I believe one of your book materials is sold out in the campus store currently.
Well, are you gonna get you're gonna get the online program Launchpad, and that's gonna come with the book, and that comes with an ebook.
Okay.
So you'll have access to it from there.
Okay. Excellent. I think that wraps up all of my questions. Good to meet you, Mr. Berkowitz.
You as well, Weston. I'll see you on Thursday.
See you Thursday.
Okay. Bye.
Hello, Professor.
Hey, girl, how you doing?
Great. How about yourself?
Good. How was day number 1?
It was all right. If I remember actually from when I took stats.
Okay. Good.
A refresher for me.
Good. Good.
The course I took over at UCLA Extensions didn't transfer over, so I have to retake it. But I do remember some of the stuff we were talking about, which is good.
Well, that's great. That's great to hear.
The problem is I have this class, but I have it with another professor.
Yeah.
I wanted to see if there's any way that I could add your class instead. I'm waitlist number 5. So it just works better with my work schedule and my other classes.
I don't mind that. I have to make sure it's approved at the math department. I assume it would be, because they basically check to make sure that you're allowed to take this course. And if you're actually enrolled in another section, you obviously are.
Yeah.
But I have to confirm it with them. So,
Okay.
what is your school ID, April?
It is 104651896.
And what's your last name? Because I don't see it there.
MONTES.
MONTES. Okay, so what I'll do is I will shoot out an email to the math department, and as soon as I know, well, come on Thursday either way, and if that's okay, or send me an email or a Canvas message, and I will respond to it and let you know. How's that?
Okay, yes. So I'll send you an email just to remind you to see if you can send me the link.
Okay.
Okay, so I'm like taking note of it right now. So I put send email for the link. And then, yeah, because I am on the wait list and I do have the other class enrolled. So I just, once you tell me if I am allowed to be in the class or not, then I will go ahead and drop the other class.
Sounds
and
like
I'll let you know about, I'll keep you posted if, and I ask the same for you.
Sounds great.
Alrighty, thank you so much.
You're welcome. Have a good night.
You too, bye-bye.
Bye.